Alright, try 4. Today we're going to be learning about the elimination method in solving systems of equations. We've already solved systems by graphing. We've solved systems by substitution. Today we're going to be doing systems by elimination. Just remember that if you always want to check your answer, graph it. And even if you're doing substitution or elimination, still graph it. Where it intersects, that's your solution. If it doesn't intersect, no solution. And if it turns out to be the same line, then infinite solution. Okay, here are the 3 steps we're going to be doing. Arrange the equations so the variables line up. Number 2, decide which variable you want to cancel. And number 3, add the equations. Alright, and number 1, they're already lined up for us. Great, yay. So we don't have to worry about that. And if you look, we have a negative 2y and a positive 2y, and if we add these equations the way they are, these 2 terms, since they're inverses of each other, will cancel out. So yay, I don't have to do anything else. I just have to add. I didn't even have to align. I could go straight to step 3. So I'm going to add, put a little 1 here. Remember, there's nothing in front of the x. There's a 1. Negative 2 plus 2 is 0. I'm not going to put 0y, just the y's are gone. And then 13 plus 7 is 20. Okay, then we solve for y by getting rid of this 4. It's touching the x, that's multiplication. So to get rid of it, we do the inverse or the opposite, which is division. So x equals 5. That's my first answer. Now the second step here, you can do 2 different things. You can get one of the equations and substitute in a 5 and solve. But I'm going to try something else. I'm going to rewrite it. And I'm going to try and eliminate the x now. Well, this would be ideal if this bottom one down here would be a negative 3x. The only way that would be a negative 3x is if I would get this first equation and multiply everything by a negative 3. So that's what I'm going to do. So negative 3 times 1 will give me a negative 3x. Negative 3 times positive 2 will give me a negative 6y. And then negative 3 times 7 will give me a negative 21. And then I'm going to add. So let's see what we get. Obviously, these will cancel out. That's right. We did that. And then negative 2 and negative 6 added will give me a negative 8y. And then 13 plus negative 21, they're different signs, so we have to subtract them and keep the sign of the larger one. So that would be a negative 8. Last thing there is get rid of this negative 8 so you cannot have y by itself. They're touching, that's multiplication. To get rid of it, we divide by the exact number that's there, and I add a 1. So our solution is 5, 1. And I can always check myself by graph. Alright, example 2. Again, they're already lined up for us. Yay, saves us a step. But there is nothing that jumps out that I can easily solve. These, if I add them, I end up getting a positive 4y, so nothing cancels out. But let's do this. Let's multiply the bottom by a negative 1. And that would change that 2y to a negative 2y. Okay, and then I can add them and cancel them out. So let me just move this down here so they're together, and I can just focus on that and ignore the original equation. That way I only focus on this bottom part. Well, now I can see that these 2 will cancel out and add everything else. So that's negative 4 plus 3x. That's going to give me a negative 1x. That canceled out, and then 16 plus 7, that would give me a negative 9. And then remember, I cannot have a negative variable, so divide by a negative 1, divide by a negative 1, x equals 9. Okay, let's do it again, but now let's pick something that'll cancel out the x's so we can eliminate that. So the thing is that there's nothing that I can only multiply a 3 by that will give me a 4. And there's nothing that I can multiply a 4 by that I could get a 3. So, and nothing I could divide by either. So just heads up. So what I'm going to do is I'm going to look at 3 and 4, and I'm going to pick the lowest common multiple, meaning 3 times 2 will give me 6, 3 times 3 will give me 9, 3 times 4. I would go until all the multiples of 3 and all the multiples of 4, and I would pick the one that they have that match. Well, obviously that's going to be 12, okay? Right? 3 times 4 is 12, and 4 times 3 is 12. So in order for us to get 12, I have to get the top part here, the top equation. I'm going to have to multiply it by 4, and the bottom one, I'm going to have to multiply everything by 3. Also, guys, this step, when you're doing this, everything needs to be multiplied. Multiply once in the equation, everything gets multiplied. So let's make it 12x plus 8y, because I'm multiplying by 1, equals 28. Okay, then the bottom one, we're going to do the same thing. I'm going to multiply by 3. Negative 3. That way I can get a negative 12 here when I multiply 3 times the 4. Negative 6y. And 18, carry 1. So negative 48. That way the 12s will line up and they will cancel out when I add. So we add them, that cancels out, and 8 plus negative 6, excuse me, is 2y. I was already jumping to the answer there. That's supposed to be a y. Then 28 plus negative 48 will give me a negative 20. And for some reason that doesn't want to write my y. Then I need to get y by itself, so I need to get rid of that 2. They're multiplying, so we divide to get rid of it. If I divide on one side, I divide on the other, and my answer is negative. So there are 2 answers. Again, I could check it by graph. Where they intersect, that would be my answer. Alright, on example 3. Again, nothing jumps out, but they're also not in order. If you notice, they don't line up. I have the x's here. Oops, sorry. I have the x's here, and those line up. But then I have the y's over here, the regular numbers over here. So we're going to have to move things around so they line up. So I need to bring this 2y over and this 1 over here. So really, initially they have to cancel out. So you always do the opposite. So that 1 is going to end up being a minus 1 on the other side. And this negative 2y is going to end up being a positive 2y. Why? Because in order to cancel out, I always have to do the inverse operation, which would be addition. So that would cancel out on the right, but then bring it over to the left. Okay? Now this will line them up, but nothing cancels out just the way it is. Okay? So just heads up. So I still have to decide which one do I want to cancel out. I'm going to just start with the easiest one, the smallest one. I'm going to start with the y's here. So I'm going to have to go with the lowest common multiple. So 2 times 2 is 4, and times 3 is 6. So 6 is the one they share. So I'm going to get this top one, and I'm also going to multiply it by 3. And this bottom one, I'm going to have to multiply by 2. That way, I'll end up with a 6y. So that's going to be 21x plus 6y equals negative 3. And then 8x minus 6y equals negative 26. Now I can add them. Okay. And these are inverses of each other. Be careful, make sure that they're not the same sign, because then they won't cancel out. Okay, so they'll cancel out. This will give me 29 when I add, and this will give me negative 29 when we add. Divide both sides by 29. Divide both sides by 29. X equals negative 1. Okay. Now, if you want, you can do the same thing and just pick the number to eliminate x. Or you can substitute yes. Let's go ahead. Focus here again. 7x plus 2y equals negative 1, and then 4x minus 3y equals negative 13. So I'm focusing here again, but now we're focusing on the x's, and I want to see, is there a lowest common multiple between 4 and 7? 7 times 2 is 14, times 3 is 21. Nope. So I guess it's just, this gonna have to be times 4, and this one's gonna have to be times 7, so then I can get up and 28. But one of them has to be negative, so I'm just gonna make this bottom one negative. Alright, so how's that gonna change my equations here? That's gonna give me a 28x, 8y, and a negative 4. Then let's do negative 7 multiplied inside the second equation. So that'll give me a negative 28x, a positive 21, right? 7 times negative 3 will give me a positive 21. And then negative 7 times negative 13. So that's 91 positive, right? Okay, big number, but it'll be okay. Alright, then it's going to be, we're going to add now. So that'll cancel out. This will give me a 29y, and these are different sides, so I'm subtracting, keep me sign the large one. Let me see if this divides into a nice number. 86 divided by 29. Incorporate it into 1. See the mistake. And I remember this fractions. I guess it could be. I'm feeling I made a mistake. Okay, so I'm going to check myself real quick by substituting that 1 into that I originally got here into one of the equations and see if I made a mistake. Because I remember getting a fraction. So that would be 7 parentheses negative 1. I'm using the first equation equals negative 2y. So I'm going to do substitution. Negative 7 plus 1 equals negative 2y. And then that's negative 6 equals 2y. Wow, this was definitely easier. Divide both sides. Y equals negative 3. And why did I not even get close to that? I made a mistake. Oh my gosh, there's my mistake. So here, I can minus 1 and give it 4 because 91 is not 86. It's 87. So when I divide both sides by 29, that's when I get the 3, but I don't get a negative 3. Why? Why did I get a negative 3 over here? Oh, this is originally a negative 2. So when I divide by negative 2, so that's positive. Okay, so that one way you could check yourself. Careful with those numbers, don't do what I just did. Okay, we have 2 more examples. Again, there are equations are not lined up, so let's move this to negative 6 over. So remember, when it comes over, it switches signs because it has to be the inverse operation to initially cancel out. So let's just say it this way: switch sides, switch signs. So that's going to become a positive 6. The negative 3y doesn't move, so we leave it there. So the only thing that moved was that 6x. Now they're lined up very nicely, and then I'm going to multiply this top one by whatever will cancel out the y, just because I think it'll be easier. So if I get a positive 3y there, then they will cancel out. So what I'm going to do is I'm going to multiply the top by a negative 3. So when I get a negative 3 times a negative y, I'll get a positive 3y. That's going to be negative 6x plus 3y equals negative 21. Then rewrite this bottom one down here, the second equation, and then add. These will cancel out. Ooh, and these will cancel out, and we're left with 0 equals 7, negative 7. Does 0 equal negative 7? No, that is a false statement. This is no solution. So if I would graph this to check myself, I should end up with parallel lines. Oh, just heads up though, if I would have ended up with 0 equals 0, that would be infinite. Okay, but it's not. But if I did, just heads up. All right, last example here. This is fractions. A lot of people don't like fractions. That's okay. All right, let's see what can we cancel out. So let's try and avoid the fraction right now, and let's just focus on the x. And let's see what we get there. And then we'll focus on the fraction a little bit. Okay, so in order for these to cancel out the x's, we're going to have to end up multiplying the top by a 3, the bottom by a 2, and then let's make one of them negative. I'm just going to make the first one. That way when I get a 6 on both of them, I'll get a negative 6 on the top, and then they can cancel out. So I'm just going to multiply that in, a negative 3. So that's going to be negative 3y, negative 24, and if you don't know your multiplications, use a calculator. The bottom, that's going to be 2 times 3 is 6, and 2 times 3 halves, I'm going to put a little 1 underneath. That's going to give me a 6 on the top and a 2 on the bottom, and 6 divided by 2 is going to be a 3. I'm just going to jump into that already. If you want to check yourself, you can use a calculator. And then 24 on the bottom. Check this out. That's negative 6 plus 6. Cancel out. Negative 3 plus 3. Cancel out. Negative 24 plus 4. Cancel out. I shouldn't say cancel out. Really, it's zeroed out. We ended up with 0x. We're going to write 0. 0, 1. We're going to write 0. It just says 0 plus 0, which is 0. We end up with a true statement and our variables cancel out. Alright, good luck.